Hi, good evening. I'm Dr. G. Srinivasu, Associate Professor, Department of Mathematics, Minister of Aeronautical Engineering, Dundigal, Hyderabad. In the present video, I would like to present the topic Basic Concepts of Line Integral. So this comes under vector integration. Already we have seen several topics in vector differentiation in the last 6 or 7 videos. Now, I would like to present the basic concepts of line integral. So, in vector integration, there are 3 integrals we are going to study. The line integral, surface integral and volume integral. The line integral means it is a single integral, and surface integral it is double integral, and for volume it will evaluate the third integral, that is triple integral. So what is the line integral? What is the definition of line integral? Any integral which is to be evaluated along a curve is called a line integral. Any integral which is to be evaluated along a curve. That means, suppose if you want to evaluate the line integral along the curve from this point to this point, that is called the line integral. Suppose if you want to evaluate the line integral along the square or along the rectangle, so from A to B and B to C, C to D, that integral is called the line integral. So along a circle, it is a 2-dimensional figure. Along an ellipse, along some curve, along some parabola. So these are called the evaluation of integrals along the curve, and these are called the line integrals. So any integral which is to be evaluated along a curve is called a line integral. Let C be any curve as shown in the figure in the XYZ coordinate system, and let f bar be any vector point function defined at every point of a curve C in the space. And now divide the region or divide the curve C into n parts as shown below. And this is the starting point is A, and which is P0, and the end point is B. The end point is treated as Pn. And here we divide the region into P0, P1, P2, P3, so on, Pa, so on, Pn minus 1, Pn. So A is the starting point P0, and we divide it as n parts, and the curve C. So the curve AB is dividing into n parts by using P0, P1, P2, P3, so on, Pi minus 1. So write Pi minus 1 like here, and this is P2, and so on, Pn. And let f bar be any vector point function defined at every point of the curve C in the space. And I am dividing the total curve into n equal parts using P0, P1, P2, so on, Pn. And also assume that let R0 bar, R1 bar, R2 bar, so on, Rn bar be the position vectors of these points. And let Qi be any point in the arc Pi minus 1, Pi. And now consider the limit summation f bar dot dr bar. What is r bar? R bar is nothing but xi bar plus yj bar plus zk bar. It is the position vector of the point x comma y comma z. And then dr bar becomes dxi bar plus dyj bar plus dzk bar. This is dr bar. And vector point function f bar is the given vector which is defined along the curve, where dri bar, delta ri bar is equal to here ri bar minus ri minus 1 bar. This is dr bar, this is delta ri bar. Now as the limit of this sum as intending to infinity, that means delta ri tends to 0 if it exists, then it is called the line integral f bar dot dr bar. You can write small r or capital R. If we maintain small r, you go it throughout with the r bar. So small r, then integral over C f bar dot dr bar. Clearly the definition is the summation f bar dot delta r bar along the curve C as n tending to infinity will give the integral f bar dot dr bar along the curve C. So the limit of the sum as n tending to infinity the lengths will be 0. Suppose as n tending to infinity, if the number of parts are infinity. So here there are n parts to divide A and B. Suppose if you use n value tends to infinity, then the distances between the points will be very less. dr is very less. Vr tends to 0. Then this summation will called as integral f bar dot dr bar along the curve C, where f bar is the function defined along the curve and dr bar is the position vector of any point r is equal to r bar is equal to x, y, p, x, comma, y, comma, z. So now, suppose the line integral means integral f bar dot dr bar. Very clear, along the curve C. So if you want to find the line integral means you are supposed to calculate integral f bar dot dr bar, where f bar is the given function and dr bar is the dxi bar plus dyj bar plus dzk bar. So now we see small. Suppose if you assume f bar is f1 I bar plus f2 j bar plus f3 k bar and r bar is xi bar plus yj bar plus zk bar, then what is dr bar? It is dr bar means dxi bar plus dyj bar plus dzk bar. Then f bar dot dr bar integral over c. Integral over c, f bar dot dr bar is integral over c, f1 I bar plus f2 j bar plus f3 k bar, the dot product with dxi bar plus dyj bar plus dzk bar. So on making dot product, we get integral over c along the curve C, f1 dx, first element, plus f2 dy, second element, plus f3, not dx, it is dz, f3 dz. So this is the line integral of f bar along the curve C. There are several applications of line integral. Suppose v bar represents a velocity vector of a fluid particle and C is any closed curve, then the integral f bar dot dr bar, here integral v bar dot dr bar along the closed curve C. So this indicates that it is along closed curve. Suppose if you write this is v bar dot dr bar, it is along the curve C. So this is need not be a closed curve, this is the closed curve. If you write the integral over the closed curve C means we are considering the line integral along the closed curve. These are the along the closed curves. These are all along circle, along rectangle or along square, along ellipse. These are all the closed curves. Suppose if you want to represent along the closed curve, that can be written as integral over the closed curve. That means you have to put circle in between the integral sign over C v bar dot dr bar. So what is circulation? If v bar represents a velocity vector of a fluid particle and C is any closed curve, then the integral v bar dot dr bar, then the integral over the closed curve C, f bar, v bar dot dr bar is called the circulation of v bar around the curve C. So that means what? So if you want to find the line integral, then you have to calculate integral f bar dot dr bar. If you want to calculate the circulation, then also you have to calculate integral v bar dot dr bar. You want to find the line integral or circulation, it is integral v bar dot dr bar. Similarly, now suppose if integral over the closed curves v bar dot dr bar is equal to 0, then the field v bar is called conservative. Conservative means there is no work done and energy is conserved. There is no loss in the energy. If integral over the closed curve v bar dot dr bar 0, then the v bar is called conservative. Conservative means the energy is as it is. That means there is no change in the energy, so there is no work done. So if you find whether the work is done or not, we find integral over the closed curve C, v bar dot dr bar is equal to 0 or not. Suppose if the circulation of v bar around every closed curve in a region D vanishes, then v bar is said to be irrotational. If the circulation of v bar around a closed curve, suppose if you take some region D and every closed curve in this every closed curve in the given region D, if every closed curve integral v bar dot dr bar is equal to 0, vanishes means 0, then v bar is said to be irrotational in the D. Similarly, the another application is work done by force. Suppose if F bar represents the force vector acting on a particle moving along an arc C, then the work done during the small displacement delta R bar is F bar dot delta R bar. Suppose if it is the curve C, and suppose if you want to move a particle from this point to this point, and suppose F bar is called the force vector. So force is applied to move the particle from this point to this point. So there is a small displacement delta R bar, then the work done by force is F bar dot delta R bar. Clear? If C is any closed curve or say any curve, and this is the particle and which is going to move by applying the force F bar by the small displacement delta R bar, then F bar dot delta R bar is called the work done by the force F bar during the small displacement delta R bar. Suppose if you want to move a particle from the point A to B, this is the small displacement. Suppose if you want to move the particle from the point A to B, then the force vector is F bar, then integral F bar dot dr bar along the curve C. The total work done by force vector F bar during the displacement from A to B is given by the line integral F bar dot dr bar. So, to find the work done, we need to calculate integral F bar dot dr bar. This is work done. To find the circulation along V bar is integral V bar dot dr bar. To find the line integral, that is integral F bar dot dr bar along the curve C. So in all the cases, whether it is a circulation or work done by force or the line integral along the curve C, we need to calculate integral F bar dot dr bar. So F bar sometimes may be force vector and sometimes may be velocity vector and sometimes may be the given function, whatever it is. So the line integral means you are supposed to calculate integral F bar dot dr bar. And another thing here is if the force F vector F bar is conservative, that is F bar is equal to grad phi. If the force vector F bar is conservative, that is F bar is equal to grad phi, then the work done is independent of path and vice versa. Suppose if you want to move a particle from A to B, and suppose if you get grad phi, if there exists a scalar potential phi such that F bar is equal to grad phi, then the work is said to be conservative vector field. Conservative means what? So the work done is independent of the path. The work done is independent of the path, and that can the force vector can be work towards like this or towards like this or towards like this or towards that is independent of the path, and vice versa. That is the point to be noted in the force vectors. So in this case, curl F bar is equal to curl grad phi is equal to 0 bar, and phi is called a scalar potential. So to show that the vector field F bar is conservative, it is sufficient to show that curl F bar is equal to 0 bar. If curl F bar is equal to 0 bar, then there exists a scalar potential phi such that F bar is equal to grad phi, and phi is called a scalar potential. So if F bar is a conservative force field, if del cross F bar, curl F bar is equal to 0 bar. So that is already, I told that once again I am seeing that del cross F bar means curl F bar is equal to 0 bar. Then F bar is said to be conservative force field. So a conservative force field is also irrotational. Irrotational means del cross curl F bar is equal to 0. So in all the cases, you need to calculate whether curl F bar is equal to 0 or not. That you have to verify whether to find whether the vector is conservative force field or not. So finally, I can say that to find the line integral, we need to calculate F bar dot dr bar along the curve C. So the curve C may be a closed curve or some path may be like that. And suppose if V bar is the velocity vector, then integral V bar dot dr bar represents the circulation of V bar along the curve C and along the closed curve C. Suppose if F bar is the force vector, Then to move a particle from this point to this point, we use integral f bar dot dr bar. So these are the 3 points to remember. Whether they may ask for finding the line integral, or find the circulation, or find the work done by force, or show that the f bar is conservative force field. So whatever it is, you need to calculate integral f bar dot dr. Then to show that f bar is a conservative force field, it is sufficient to show that curl f bar is equal to 0. Now we will go to see some examples. If f bar is a vector, so given some vector f bar is a clearly, there is no k term, 3xy I bar minus y square j bar. That means it is defined on the two-dimensional space. J bar, suppose xyz is there, then it is a three-dimensional. Only xy is there, then it is a two-dimensional space. So given f bar is a vector point function and there is no k bar term, so it is a vector defined in the two-dimensional space. Now what you have to do is you have to evaluate integral f bar dot dr bar along curve C, where C is the curve y is equal to 2x square in the xy plane. So what is y is equal to 2x square? This is the curve. Y is equal to 2x square. So this is like parabola. X square is equal to 1 by 2 into y. That means what? X square is equal to 4ay. It is like 4a is equal to 1 by 2. So the parabola is like this, and this is the point 0, 0, and we call it as vertex. Or let another point. And what is 1, 2? And extend this 1, this is 2, and this point is 1, 2. So this is the parabola, and here the point 0, 0, and 1, 2, it is the point on the parabola. Now what we have to calculate is integral f bar dot dr bar. Integral f bar dot dr bar. So already given function f bar is equal to 3xy I bar minus y square j bar. And what is dr bar? Dr bar is dxi bar plus dy j bar. So on making dot product, f bar dot dr bar, f bar is 3xy I bar minus y square into j bar, dot product with, what is dr bar? That is dxi bar plus dy j bar. So on making dot product, you will get 3xy dx minus y square into dy. This is integral f bar dot dr bar. This is integral f bar dot dr bar. Now we have to consider the curve C. What is the curve C? The curve C is the parabola from this point to this point. The curve, what is the curve? Given the given curve, y is equal to 2x square. Then what is a dy? Dy is equal to 4x dx. Am I right? And x varies from 0 to 1. X means you have to consider the abscissa from the edge points, vertex and another point 1, 2. So if x is the limit, then a variable limit, then you have to take 0 to 1. If y is supposed to take, then 0 to 2. So that is your choice. So now what is, I will write here integral. Now what is integral over curve f bar dot dr bar is equal to 3xy dx, as I have seen 3xy dx minus y square dy along the curve C. So what we have already from the given curve, y is equal to 2x square, y is equal to 2x square, and dy is equal to 4x dx. 4x dx. And also we have the limits that x is equal to 0 to 1. X varies from 0 to 1. So all the information is available. Now we need to calculate integral 0 to 1. Integral 0 to 1. I am taking x as a limit, or you can take y also limit. So this is 3x, y means 2x square. Here I am writing just to see. 3x, y means 2x square. Y is equal to 2x square. And dx as it is minus, what is y? Again it is 2x square whole square. And what is dy? Dy is equal to 4x dx. 4x dx. I write here integral. This is dy. Dy is equal to 4x dx. So I write here. Integral 3x into y means 2x square dx minus y means 2x square whole square into dy means 4x dx. So that also I am writing here. That is integral 0 to 1 6x cube minus 2 2s are 4, 4 4s are 16. Am I right? X power some 5 of dx. So just I will verify. 3 2s are 6x cube first term. Second term 2 square 4, already 4 16. X power 4 into x, that is x power 5 dx. So on integrating 6 into x power 4 by 4 minus 16 into x power 6 by 6 between 0 and 1. So substitute the limit 6 by 4 minus 16 by 6 and lower limit both are 0. So now on taking the limit, the LCM is 12. 4 3s, 3 6 are 12. 3 6 are 18. 4 3s are 12. 3 2 are 6. 4 3s are 12. 3 6 are 18 minus 6 2s, 16 2s 32. So minus 17 by 12. So is it right? Just check it out. 6 by 4 minus 16 by 6. So 12, 18 minus 32. That is minus 14 by, minus 14 by 12. That means what? Minus 2 sevens, 2 sixes. So minus 7 by 6 is the required answer. This is minus 14 by 12. That is minus 7 by 6. Now I will do another problem. So here also f bar is given. The vector 3x square I bar plus j bar plus zk bar. The force field. Find the work done. So work done means integral f bar dot dr bar we have to calculate. So I am writing here what is given. Given f bar is equal to, so 3x square I bar plus j bar plus zk bar. So clearly it is defined in the along the line from 0 0 0 to 2 1 3 in 3-dimensional space. This is x y z, x y z, and this is the point 0 comma 0 comma 0, and this is somewhere point 2 comma 1 comma 3. So this is the path along the line from 0 0 0 to 2 1 3. So we have to find the here, and f bar is the defined curve and c is the this curve. Clear all of you. So it is f bar is 3x square I bar plus j bar plus zk bar. Then what is a dr bar? Dr bar is dx I bar plus dyj bar plus dzk bar. Then f bar dot dr bar. F bar dot dr bar means dot product of the two vectors, that is 3x square I bar plus j bar plus zk bar. The dot product with the dx I bar plus dyj bar plus dzk bar. So on making the dot product, I bar dot I bar 1, I bar dot j bar 0, I bar dot k bar 0. So only I bar dot I bar 1, j bar dot j bar 1, k bar dot k bar 1, remaining all zeros. That means what you will get? 3x square dx, that is one term. And here only dy plus z into dz. Zk bar dot product with the dzk bar. So k bar dot k bar 1, that is z dz, this is f bar dot dr bar. It is a scalar function. Now what we have to calculate is integral f bar dot dr bar. So we have to use this function as f bar dot dr bar. Now we see from 0 0 0 to 2 1 3. So that I can do very easily. What I can do here is integral f bar dot dr bar along the curve c is equal to integral. So what is the function? 3x square dx plus dy plus what is the other term? Z dz. Z dz along 0 0 0 to 2 comma 1 comma 3. I think the point is 2 1 3. Right. Clearly, so here it is a pure function of x, it is pure function of y, it is pure function of z. So you can substitute the limits as it is. That means 3x cube by 3 plus integral dy y and integral z dz, z square by 2. The limits are from 0 0 0 to 2 comma 1 comma 3. So 3 3 cancel. On substituting the limit, upper limit, x for 2, 8, 2 cube, 8, y for 1 plus z for 3, 3 square, 9 by 2. This is the first set, upper limit. What is lower limit? So x for 0, y for 0, z for 0. The lower limit is 0. So 9 plus 9 by 2. So 18 plus 9 by 2, that is equal to 27 by 2, which is the required work done by force, F bar dot dr bar, 27 by 2. Am I right? So in that way we can do the problem. Just we find F bar dot dr bar and find the limits of integration. Here the limits are easy. That's why we don't have any issue in substituting the limit and integrating. And sometimes you have to consider the line also. That will do in another example. So this will be the problem. And also we have to do the same similar type of problem, and this is the last problem for this session. And F bar is the given vector in two-dimensional space. And here we have to observe what curve or what closure curve or what curve is given in the region. So it is a rectangle. In the first problem, it is a curve, parabola. In the second problem, we have seen along the point line in the three-dimensional space. And in the example here, there is a rectangle in xy plane. This is x-axis and this is y-axis. X is equal to 0 means y-axis. X is equal to 0 means this is x is equal to 0, y-axis. And x is equal to a. X is equal to a means somewhere it is. X is equal to a. So the line passing through a comma 0. And this is, we know that 0 comma 0. And y is equal to 0. Y is equal to 0 means what? X-axis. Y0 means x-axis. And y is equal to b. Y is equal to b. This is y is equal to b. The line parallel to x-axis. So we have to find the line integral along AB, along BC. BC means a comma b. X is a, y is b, a comma b. And this point is 0 comma b. So we have to find the line integral along the closed curve rectangle. That means it is sufficient to find along AB, along BC, along CA, along CD and along DA. A, B, C, D. Along AB, along BC, along CD, along DA. Right? So before that we calculate integral F bar dot dr bar. Now integral F bar dot dr bar is equal to integral. So the given function x square plus y square I bar plus minus 2xy j bar dot product with. So dr is on dxi bar plus dy j bar. So no need of considering z term. So this is integral x square plus y square dx minus 2xy into dy along the curve C. So you can assume it as along the closed curve C also, because it is the rectangle which is the closed curve always. Now I am studying case 1 along AB. Along AB. This is along AB. So along AB means the equation is here. The equation is y0. Y0 means dy also 0. Y0 means dy also 0. But the x is a variable which varies from 0 to a. X is a limit from 0 to a. So initially x0, it is 1, 2, 3, it is some a. So x varies from 0 to a along the line AB. So on substituting this integral F bar dot dr bar along C1. So let it is C1, C2, C3, C4. So along C1 means what? Along integral along C1. F bar dot dr bar x square plus y square dx minus 2xy dy. So on substituting the points y0. Y0 means this is 0 and this also 0. Only you will get x square dx. So here observe dy 0. That means the second term 0. dy 0 or y0, entire second term 0. Here also y0. Only you will get x square dx. So what is x limit here? 0 to a. So limit also we have that integral 0 to a x square dx or x cube by 3 between 0 and a, or this is a cube by 3. That is the first value along AB. Along AB the value is a cube by 3. Similarly, we have to calculate along BA. Along BA. So you'll write once again integral F bar dot dr bar So this should be easy to integral x square plus y square dx minus, what is the function? 2xy dy. 2xy dy. So keep this. Now case 2. What is case 2? Case 2 is along BC. Along BC means this is along BC. This is along BC. So the equation of BC is x is equal to a. The equation of BC is x is equal to a. Then what dx is equal to 0. XA means on differentiating, you will get dx is equal to 0. And what about the constant? Constant x is similar. X is a always. But y is varies from 0 to b. So y varies from 0 to b. You see this, it is abscissa and ordinate. Abscissa AA is same and y varies from 0 to b. So now integral f bar dot dr bar along the curve C2. C1 already over. C1 means along AB. C2 means along BC. That is integral f bar dot dr bar. X is equal to a. That is a square plus y square into dx means 0. Dx means 0 minus, and here 2x means what? A, y, dy. So dx 0. So the entire first term 0. So limit x is y limit is 0 to b. So finally what you will get? Integral 0 to b. This entire term 0 because sum of the product term is 0 minus 2ay dy or 2ay square by 2 with minus sign between 0 and b. So 2 to cancel, minus a b square. That is the second equation. So I am putting y for b, then you will get minus ab square and lower limit is 0. And this is the line integral along BC. Similarly, we will do along CA also, along CD. So case 3. So here I will do along CD. AB over BC over along CD. So what is CD? See this rectangle along CD. So what is the equation of CD is y is equal to b. The equation of CD is equal to y is equal to b. And here b constant, b is constant throughout the curve. But a is varying factor from x varying from a to 0. Here equation y is equal to b and x varies from b to 0. And see, this is b to y constant, b, y is equal to b always. But x constant, x varies from a to 0. Reverse case, a to 0. So here I will write a to 0. And y is equal to b means dy is equal to 0. Now integral along C3 f bar dot dr bar is equal to integral along C3 means x varies from a to 0. And what is the function? X square plus y square. What is y square? Y is, we can replace by y by b. So it will be b square of dx minus 2 into x into b into dx, dy is 0. Dy is 0. So only first term will get integral x square plus b square dx between the limits a and 0. So on or integration x cube by 3 plus b square x between a and 0. So substituting for x, it is 0, 0, lower limit minus a cube by 3 minus a cube b square into a. B square into a. This is the value, that is minus a cube by 3 minus b square into a. This is case 3 evaluation. Case 3 means along CD. And finally what to do? Along, last one, along DO. Along DO or DA. So if I assume along DA. So what is DA equation? This is the line and it is y-axis means x is equal to 0. The equation is x is 0. So dx also 0. This point is what he has given. I'll see once again. It is 0 comma b. 0 comma b. And this is 0 comma 0. So x 0 means dx 0. Here y is a variable factor. Y varies from b to 0. along this only I am calculating from b to 0. So integral f bar dot dr bar along the curve dA. This is C1, C2, C3, C1, C2, C3, C4. So this is integral f bar dot dr bar x square plus y square dx minus 2xy dy along the curve C4. So this is here dx 0 means entire first term 0. So minus second term also 0. So entire value 0. So we have evaluated all the integrals along the curve C1, C2, C3, C4. That means it is entire rectangle. So now the sum of all these is the required line integral. So now integral f bar dot dr bar along the closed curve rectangle is equal to, what is the first value? So I will see here. The first value, case 1, a cube by 3 minus ab square second value, third value minus a cube by 3 and what is the other value? Minus ab square minus a cube by 3 and plus 0. So on adding these two gets cancelled. The value is minus 2ab square, which is the required line integral along the rectangle, along C1, along C2, along C3, along C4. So I have calculated all the values along C1, C2, C3, C4 and on adding all these, you will get the line integral along the curve CF bar dot dr bar. This is called you can call it as a force vector F bar dot dr bar. Clearly here is given, just evaluate F bar dot dr bar. Or if you assume this as an example as the force vector F bar, if it is given, then F bar dot dr bar is the work done by the force vector F bar. So in this way we can prove the problems in line integral, and we will go for some more problems in the next video. And thank you for listening to my video. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.